Hello, here we're going to take a brief look at right triangle trig. If you're watching this video, you have probably seen a function that looks like this. Sine of alpha equals to, let's say, A out of C. A is a side, C is a hypotenuse. What sine is just a definition of how to set up relationship between an angle and two sides of a right triangle. Sine of an angle calculates ratio of sides. Same goes for cosine, tangent, cosecant, secant, cotangent. The reason this is important is because usually you will have 2 out of 3 quantities. Right now you have one side, other side, and an angle. So when it comes to big problems, word problems or picture problems, you will have 2 out of 3 quantities and you will have to calculate the other one. It's useful to remember that sine of an angle calculates ratio, and the inverse of that, sine to the -1, it's not 1 divided by sine, but on your calculator you will have sine inverse, and you will plug in ratio of sides. If you're given a ratio of two sides of a triangle, using function of sine to the -1 of that ratio will calculate the angle of that ratio. So depending on the situation, you should know how to use these functions. The 6 trig functions. Here I'm going to begin with 3 because the other ones are just inverses. Your trig life becomes so much easier once you memorize what these definitions are, because all they are is just a setup with respect to an angle. So here I have a right triangle. So this is my right corner triangle. It doesn't matter how you label the legs, the ones that are protruding from the 90-degree angle. It's very, very important that you know which one is C or hypotenuse. This is crucial when it comes to using Pythagorean theorem and word problems. So I'm just going to arbitrarily call this A and this B. The setup of sine, cosine, and tangent all depends on where the angle is, where your reference angle is. So to calculate ratio of sine of theta, you take the length of the side that is opposite to theta and you divide it by hypotenuse. Cosine theta, you take the adjacent to the angle theta. Adjacent means the side that is touching the angle, and divided by hypotenuse. For the tangent theta, you take the side that is opposite to the angle theta and you divide it by the side that is adjacent to the angle theta. So let's say my theta is right here. To calculate sine, I will take the opposite side. The opposite side from theta is B, and I will divide it by hypotenuse, and we called hypotenuse C in here. Cosine, you take the adjacent side to theta, which is A, and you will divide it by hypotenuse, which we called C. And for tangent, you take the opposite side from theta, which is B, and you divide it by adjacent side, which we called NA. Now, your trig life will become so much easier once you memorize these definitions. A long time ago, I thought I had trouble with trig, and all it was is that I didn't really have this memorized very well. I did say 6 trig functions. I only have 3: sine, cosine, and tangent. The other 3 are reciprocal, meaning you flip the fraction. So sine has reciprocal of cosecant of theta, and you just flip this ratio, we get c divided by b. So it's a hypotenuse divided by the opposite side. And cosine has an reciprocal of secant theta, and you flip that fraction, you get c out of a. Tangent has reciprocal of cotangent. That's the easiest one to remember. And cotangent of theta is a divided by b. Now, if I have angle alpha over here, I will have similar numbers to use to set up sine, cosine, and tangent, except that my answers will be slightly different. So sine of alpha is opposite side from alpha is a, and I want to divide it by hypotenuse, which is c. Reciprocal of sine is cosecant of alpha, and that ratio will be, you just flip the fraction, c divided by a. Then we have cosine of alpha. Sine, cosine, and tangent are the most important ones. So cosine of alpha will be adjacent side, which is touching alpha, is b. I'm going to divide it by hypotenuse c. Once you know what cosine is, you can do the reciprocal, which is secant alpha. And this will be c divided by b. And last but not least, tangent of alpha equals to opposite from alpha is a, adjacent to alpha is b, and the reciprocal of tangent alpha is cotangent of alpha, and you just need to flip the fraction. b out of a is our answer. Now, before we move on, I want to show you something about tangent. Tangent has an identity saying that tangent of theta is equal to sine of theta and divided by cosine theta. And I'll get back to it a little bit later on. I just want to show you that it works. So let's say tangent of theta. So our tangent of theta was b divided by a. It should be equal to sine of theta. Sine of theta is b divided by c. And we need to divide it by cosine of theta, which is a divided by c. How do we divide fractions? Left side will stay the same, so we have b out of a equals to, let's keep the first fraction, so we have b out of c, change division into multiplying, flip the second fraction, c out of a. I hope you can see it now. C and c will cancel, and we have b out of a equals to b times 1, b, 1 times a. So this is a true statement. Here's your first proof. I did want to show you this because I'm going to get back to it when we do special angles. Here we have a right triangle, and we have angle CAB being theta. Here we have BC equals to 5, BA hypotenuse equals to 13, but we are missing CA. Now luckily for right triangle there is Pythagorean theorem, which is c squared equals to a squared plus b squared. It doesn't matter which one you call a or b, but it's very, very important that the side across the right angle is labeled c. So we have c squared is 13. The convention is you label the side the lowercase letter of the angle opposite to it, so 5 will be a and CA will be little b, but it does not matter how you label this as long as you figure out which one is the hypotenuse. It has to be by itself on one side. So a is 5 to the second plus b to the second is our unknown. 13 squared is 169 equals to 5 squared is 25 plus b to the second. Let's solve for b. Minus 25 minus 25. So we have 144 equals to b to the second. Second power will cancel out with the square root, so I'm going to take the radical on this side. Whatever I do to one side, I'll do the same to the other side. So square root on both sides. So square root and the second power cancels. We have b equals to 144 can be rewritten as 12 times 12 or 12 to the second power. Once again, square root and the second power cancel. So we got b equals to 12. This is not our solution, this is just the missing side. Now we need to find the value of each of the 6 trig functions. So we need to find sine of theta. Sine is opposite over hypotenuse. Opposite of theta is 5. Hypotenuse is 13. Once you know what the sine is, you already know what cosecant is. And you just flip the fraction, 13 out of 5. Then we have cosine of theta. Cosine is the adjacent, which is 12 out of hypotenuse, 13. Sine, cosine, and tangent, they just calculating ratio of sides. Once you know what cosine is, you know what the secant is. Secant of theta is, you just flip the fraction for cosine, 13 out of 12. And last but not least, tangent of theta is opposite, which is 5, divided by adjacent, which is 12. Then reciprocal of tangent is cotangent of theta, and we just flip the fraction, 12 out of 5. Once you know the definitions for sine and cosine and you have those fractions, sometimes it's tricky to remember which one exactly is the reciprocal. It's easy for tangent and cotangent, but cosecant and secant, they sound the same. Especially since those are just names of definitions you had to memorize. But if your main function starts with s, reciprocal is cosecant. If the main function starts with c, reciprocal is secant that begins with s. Hopefully that is easy to memorize, or if you have memorized all 6 definitions, that's even better. So you may or may not have had to memorize special angles so far, which are 30, 45, 60, 90 ratios. Here's a nice shortcut for figuring out what those ratios are if you have forgotten your tables. If you have memorized those tables already, you can just shut off the video. But here we go. You start at 0, 0, 1, 2, 3, 4. You take a square root of this whole thing and you divide the radical by 2. From left to right, you will have sine of 0 degrees 30, 45, 60, 90-degree angles. From right to left, you will have cosine of 0, 30, 45, 60, 90 angles. Notice that the values are complementary, meaning they add up to 90 degrees, because in a right triangle, this is 90 degrees. And the sum of all three angles is 180 degrees. If we take away the angle that we already know, 90, that leaves us 90 degrees for the sum of these two angles. I can talk for a while about why these are special angles, but these are special angles because they produce exact values. They have nice ratios, even though some of them have radicals in there, but they are not crazy, non-repeating, irrational decimals. Let's do some examples. Let's say I have to find the exact value of sine of 30 degrees. I go to the sine of 30 degrees, which is here, and it has radical. Under 30 degrees is 1 out of 2. So sine of 30 degrees is 1/2. Let's say I need to find cosine of 30 degrees. I will start with the top row, and cosine of 30 degrees is here, and that will give me radical 3 out of 2. Let's say sine of 45 degrees is, you go to 45 degrees, which is square root of 2 out of 2. Now, some of the fun ones are sine of 0 degrees. We have square root of 0 out of 2. Square root of 0 is 0, divided by 2. 0 divided by 2 is 0. Let's have cosine of 0 degrees. We have square root of 4 out of 2. Square root of 4 is 2 divided by 2. This simplifies into 1. This is fun, said and done, but the tricky part comes when you have to calculate, let's say, tangent of 30 degrees. This reference diagram has no indication of what tangent of 30 degrees is, but I have shown you the identity before, saying that tangent of an angle will be equal to sine of that angle divided by cosine of that angle. So tangent of 30 degrees equals to sine, we have it equal to 1/2 from here, divided by cosine of 30 degrees is square root of 3 out of 2. So tangent of 30 degrees is equal to 1/2, change division into multiplying, flip the second fraction, 2 out of square root of 3, 2 and 2 will cancel, so tangent of 30 degrees is equal to 1 out of radical 3, and the only thing you need to do is rationalize the denominator by multiplying the denominator and numerator by radical 3. This will give us 1 times radical 3 out of radical 3 to the second, or 9, square root and the second power cancel, and we have tangent of 30 degrees equals to radical 3 out of 3. Now this is not the main way of doing this, but because you have probably seen special triangles of 45, 30, 60 degree triangles or tables, but if you're in a pinch, it's a nice way of remembering sine and cosine. Tangent is the only one that will require you to do some calculations with fractions. So I would recommend practicing deriving this fraction first and then seeing whether or not you can handle simplifying for tangent values. If not, it's only 5 things to memorize from a table. That's all for now.